Next items on the agenda are presentations by the panel leadership for the state of the panels that make up the NSRP. And on behalf of the program administration team, I just want to say how much I really appreciate being able to work with these panel leaders throughout the year. First up will be Mr. Jason Farmer of the Electrical Technologies panel from Ingalls Shipbuilding. Jason.
Good afternoon. My name is Jason Farmer. I work for Ingalls Shipbuilding and serve as the panel chair for the Electrical Technologies panel. Thank you for your time this afternoon. It's a true honor to present on behalf of the Electrical Technologies panel. The panel's mission is to reduce the cost associated with the installation and operation of shipboard electrical systems during new construction, as well as maintenance and modernization activities. Our panel works to foster communication among Navy programs, electrical system integrators, ship designers, and shipbuilders, as well as the entire NSRP program. The purpose of our panel is to evaluate and transition improved electrical system technologies, processes, and specifications. We do this through a collaborative framework across the shipbuilding industry. The overall goal of the Electrical Technologies panel is to reduce the cost and improve shipboard electrical system performance. Our panel focuses on many areas associated with electrical system installation. These focus areas are listed here and include improving total ownership costs, technologies that improve energy efficiency, methods to improve electrical system performance, and ways to improve safety, both of the workforce as well as the ship's crew. The panel members have led many efforts focused on improving shipboard electrical systems. In the following slides, I'll give an overview of some of the recent panel projects conducted by the project teams. Many of these projects will be presented later this week. I encourage you to reach out to the respective project leads and project teams for more details on each of these projects. The panel also participates in numerous technology transfer opportunities across the industry. Just an example of some of these events includes the SDMT Maritime Convention, Machinery for Failure Prevention Technologies, or MFPT's annual conference. We participate in various NAVSEA working groups and the annual NSRP Day at NAVSEA. Good afternoon. My name is Jason Farmer. I work for Ingalls Shipbuilding and serve as the panel chair for the Electrical Technologies panel. Thank you for your time this afternoon. It's a true honor to present on behalf of the Electrical Technologies panel. The panel's mission is to reduce the cost associated with the installation and operation of shipboard electrical systems during new construction, as well as maintenance and modernization activities. Our panel works to foster communication among Navy programs, electrical system integrators, ship designers, and shipbuilders, as well as the entire NSRP program. Recent and ongoing efforts are focused on improving electrical connections and testing processes. The first two projects are focused on improving installation time and extending the lifetime performance of electrical connections. The Safer Inspection project focused on developing methods and technologies to safely inspect bolted electrical connections and medium voltage electrical switchgear. The recommendations developed by the project team have transitioned to new systems and are being used on current efforts in the development of high temperature insulated bus pipe for Navy platforms. Ways to improve lifetime performance of shore power connections was developed through a new testing approach. As seen in the bottom pictures, a new test system was developed and evaluated through field tests on a ship under construction. The test method aims at reducing or eliminating catastrophic equipment damage associated with faulty electrical connections. The Electrical Connector Standardization Project is an active project focused on reducing the large number of circular connections in ship designs. This is a joint panel project with the Ship Warfare System Integration Panel. The project team is identifying opportunities to improve commonality as well as reduce cost. This project will be briefed later this week and during the Electrical Technologies panel meeting. I encourage you to participate and gain more knowledge in that area. The panel has worked several recent projects focused to improve shipboard cable installation. As shown in this slide, projects identified and evaluated new cable tray options, new transit devices, and cable materials. Significant cost reduction opportunities were identified through these projects, and transition opportunities are being pursued. Recent projects in the area of fiber optics have focused on fiber optic connections, as well as new test methods to increase efficiency of the testing process. A commercially available testing system was identified by the panel as an opportunity to improve fiber optic testing in chip construction environments. Benefits of this test approach include significant time savings for testing processes and improved data to the test technician. The project team is working with NSWC Dahlgren to evaluate an optical time domain reflectometer or OTDR system for the use in Mill Standard 2042 testing. The Alternatives to Fiber Optic Connections project evaluated the use of fusion splicing over typical fiber optic connector installation. The project identified significant savings and performance benefits for applications where a fusion splice can be used. The benefits of this project were later used in a recent project that addresses equipment level fiber optic connections. Typical connections are made using a multi-pin fiber optic connector that are fabricated on the deck plate. This project evaluated options and developed new prototype hardware for enclosures that can be used and to install a fusion splice. The pictures at the bottom of the slide show the prototype designs that were fabricated in the project. The early stage prototype is shown to the right, and the final prototype middle picture. Recent projects in the area of lighting have evaluated new ways to reduce both acquisition and sustainment cost of shipboard lighting systems. The advanced topside lighting system project surveyed top maintenance issues associated with topside lighting fixtures. New, more advanced lighting technologies were evaluated for use in these applications. Recent projects are also focused on interior lighting. A new study was conducted to evaluate the feasibility of low voltage lighting system approach. The low voltage approach provides significant cost savings opportunities from the reduction of ground points required for light fixture installations. A follow-on project is currently underway to develop a low voltage light fixtures that use organic light emitting diodes. The prototype OLED fixtures have been designed and are currently being fabricated. These fixtures will be evaluated and tested at 2 shipyards in the upcoming months. These projects have identified several opportunities to reduce cost and improve performance of shipboard electrical systems. This slide highlights just a few of the opportunities from recent panel projects. In the area of electrical connections, new methods were developed and evaluated to improve safety during the inspection process. The use of IR windows and medium voltage cabinets was evaluated and has now transitioned. The new methods have been incorporated in MIL DTL 32483. Additionally, the use of fiber optic sensors was evaluated as a follow-on project. The sensor technology is now being used to monitor the voltage connection points in insulated bus pipe systems. The fiber optic test enhancement project has identified significant improvements in the time to test using this approach. Over 40,000 man-hour savings have been identified through just the first stages of this project. The Advanced Lighting System project has developed a set of recommendations for topside lighting on multiple ship classes. The project identified new technologies with significant cost-saving opportunities greater than 25%. Projects focused on fiber optic connections have identified over 70% savings when using a fusion splice instead of your standard shipboard fiber optic connector installation. The new splice enclosure concept that's shown here provides a $300 to $400 savings per connection, quite a substantial savings. The new cable tray the hardware evaluation has targeted over 10% improvement in the area of cable installation processes. A previous electrical project developed initial concepts for a flexible test adapter to be used in electrical testing processes. Through follow-on efforts with Mantech, these concepts have been matured and transitioned. The flexible concepts developed reduced the number of test adapters by over 75%, making the broad use of automated circuit testing more cost-effective. These are just a few examples of benefits from the panel's activities. Additional information and a full project summary is included in the project final reports accessible through the NSRP website. Many of the projects will be presented later this week by the respective project teams. I encourage you to reach out to the project teams for additional detail on each of these projects. The Electrical Technologies Panel typically meets 3 times per year. Our first planned meeting of 2020 was planned to be held in San Diego with a tour of General Atomics. At the onset of the pandemic, we moved all of our meetings to our virtual format. Through this format, we were able to maintain 3 meetings, one in the spring, one in the summer, and one in the winter. As shown in the graph to the right, panel meetings attendance has remained strong and our panel members have remained active. Panel membership have supported technology transfer through industry events. Over this past year, we participated in the Navy Maritime Convention, the NAVSEA Shore Power Working Group, as well as the NSRP Day at NAVSEA. As mentioned in the previous slide, the Electrical Technologies Panel typically meets 3 times per year. We work to have joint meetings with other NSRP panels for cross collaboration within the program. We try to hold our meetings at various locations from East Coast to West Coast and include facility tours where possible. The pictures to the right give just an example of a few of our tours from panel meetings. The picture at the top is from our meeting at Florida State University. That meeting included a tour of the Center for Advanced Power System, or FSU CAPS, where insulated bus pipe was being tested. We have also had tours at numerous shipyards. The pictures here are from our tours at the U.S. Coast Guard base out in Baltimore and our meeting at BAE Shipyard in Jacksonville, Florida. Our panel meetings typically focus on a technology area and include focused presentations. The discussion on our meetings typically falls within the areas listed here on the slide. We'll have presentations in these areas during our meeting this week. On behalf of the panel members, I encourage you to join us at our upcoming meetings. We'll meet tomorrow at 1 o'clock Eastern. Our summer panel meeting will be in a virtual format and will be held in the May to June timeframe. I hope to see you at one of our upcoming meetings. Please let me know if you have any questions. Thank you.
Welcome, everyone. Thank you for joining our virtual session. My name is Monika Skranska, and I am the current Ship Design and Material Technologies Panel Chair. So to start off, here is our current panel leadership. Like I said, I am the panel chair. We have Vicky Dugokeki as our panel vice chair. Dan Sfiligoy is our major initiative team lead. And Alicia Harmon is our major initiative assistant team lead. So the mission of our panel is to increase capabilities and reduce cost through the complete design spectrum, meaning from the very initial concept design stages all the way to the final stages of detailed design. And we focus on the use of advanced materials. And our ultimate goal is to support rapid and effective development, construction, sustainment, and disposal of next generation vessels. Here are our SDMT specific focus areas. So to summarize, our panel focuses on improving ship design throughout the entire design process, improving tools which create those designs, including various CAD software, as well as analysis tools, investigating material technologies and processes which reduce part count and total ownership cost, and improving current ship specifications and regulations which drive all those designs. We achieve this through investigating new technologies and incorporating them into commercial and naval rules. We also aim to collaborate with other panels on topics that are common to us all. And we achieve this by holding joint panel meetings. So what is our benefit to the Navy? So our panel creates a very unique environment for shipyards who could be considered competitors to come together and collaborate on research projects. And since many of our projects also require buy-in from the Navy, our panel also provides an opportunity for the shipyards and the tech warrant holders to come together and investigate solutions to problems that can benefit us all. And the results of these collaborations improve our shipyard's capabilities and in turn contribute to building a more secure and capable Navy. And our panel also works to align our technical initiatives, which can be found in our technical investment plan, with the needs of the Navy. And an example of this is our flexibility and modularity initiative number 6, which aligns with NAFC's flexible ship initiative. And now, as far as the benefit to the shipbuilding and ship repair industries, many of our projects which benefit the Navy also benefit commercial shipyards and vice versa. So actually, many of our projects are shipyard agnostic and benefit multiple shipyards at a time. And our panel also provides a collaborative environment that allows shipyards to investigate commercial technologies in application to shipbuilding. And an example of those are our 3D printed castings project and our mechanically attached fittings project. So both of those projects partner with a commercial company. It was Meld for castings and Viega for mechanically attached fittings. But since they also required Navy's buy-in, they partner with their respective tech warrant holders, Justin Retaniata for additive manufacturing and Bill Carver for machinery fluid systems. And here are our 2020 SDMT panel projects. These were selected in late 2019. Some of these projects just completed and others are about to complete. And all of these will be presented in our breakout session. So if you're interested in finding out more, please be sure to join our breakout session. So our first project is scaling up of 3D printed castings led by NASCO, along with the company Meld, NAFC, and shipyards Ingalls, BIW, and Electric Boat. And the benefit of this project is the development of an additive manufacturing alternative to castings. The second project also deals with additive manufacturing, and its title is Simulation Workflow Development for Additive Manufacturing. The lead on this project is ETA, and other participants include NAFC and shipyards Ingalls, BIW, and Newport News. And this project improved the prediction of AM part performance to help speed up design and to help with model-supported qualifications. Our third project is standardization of watertight hatches and scuttles. The lead on this project is Ingalls, and this project aims to cut costs by reducing part count and multiple variants. And this project was proposed due to the success of the standardization of watertight doors. Our fourth project is titled ASTM F1387 Testing for Mechanically Attached Fittings. And the lead on this project was BIW, along with the help of NAFC, Ingalls, Viega, and Southwest Research Lab. And this project successfully approved a new type of fitting, which significantly cut onboard installation cost. And this project will be getting implemented on DDG 51. And again, like I said, all these will be presented in our breakouts, so please join us if you'd like to find out more. So now going back to 2019, here are our 3 previous projects. They include joint operable standards for containerized modules led by NASCO. The benefit of this project is cutting cost of multiple variants and streamlining hookup design, as well as installation. The second project is Compass, also led by NASCO, and the benefit of this project was the creation of a program for tracking and answering comments that reduced cost and ensured that the comments got submitted on time. Our third project is knowledge provisioning to improve and simplify ABS digital compliance, led by AROS, and this project ensured timely and accurate adherence to requirements. And the success of this project resulted in a follow-on RA. And you can request any of these projects from our NSRP website if you're interested in the final reports. So our panel has organized many successful meetings and tours, and I would like to go over them quickly just to give you a feel of what our panel does. So in the spring of 2018, we held a meeting with the theme of advanced manufacturing and design in Chicago. And we had 2 very interesting tours. We toured MHUB, which is an innovation center for product development and manufacturing. And we also toured DMDI, which is a DoD funded center. They are part of Manufacturing USA, and their focus is on digital manufacturing and design innovations. And then in the fall of 2018, we traveled to Dallas. We paired up with CAMEX, which was a composite and materials conference. And this was recommended to us by NAPSI's Dr. Maureen Foley. Now, looking back at 2019, we held our spring meeting at Cape Canaveral with the theme of NASA Tech Transfer. So NASA scientists came out and joined our meeting and presented on technologies which could also potentially be applicable to shipbuilding. And examples of these are the corrosion-resistant coating and phase mass coupling. And we toured the Kennedy Space Center. Then in the fall of 2019, we held our meeting in Buffalo, New York, with the theme of additive manufacturing. We had 2 days of presentations on additive manufacturing from leaders in the industry, as well as regulatory bodies, including NAPSI, ABS, and NIST. And we toured EWI's additive manufacturing facilities. Now, looking back at 2020, obviously it was a much different year compared to our typical years filled with inspirational tours and in-person meetings. However, we managed to adapt, and our panel held 3 successful virtual meetings as listed here on the slide. We also participated in SNAME's virtual poster session, and we attended NSRP Day at NAPSI in November using the zoom.gov platform. And just for clarifications, these pictures are from NSRP Day at NAPSI 2019, not 2020. So at the NSRP Day at NAPSI, we had great discussions going on our 2 additive manufacturing projects. We had lots of Navy interest in those, and we also got positive feedback on our mechanically attached fittings project, which is always great to hear. So now this table here shows the 22 projects which got submitted to us in 2020. So as you can see, this was a very popular year for us. I thought that maybe because we went virtual, we might not get as much participation, but actually the opposite turned out to be true, and we got more submittals than ever. So I just wanted to show these to emphasize that there's a high level of interest in our panel. And then the 3 projects that made it to the top were the development of additive manufacturing capability for copper nickel seawater exchangers submitted by ElectroWatch, then using artificial intelligence to simplify provisioning of Navy standard requirements submitted by AROS, automated label plate generation submitted by SSI, and our joint project with business technologies was digital twin maturity model development and implementation guidance submitted by ABS. So to end on a positive note, one good thing that came out of our virtual meetings is that we were able to increase participation as shown here on the chart. So even though we couldn't meet in person, network, and attend our exciting tours, we were able to increase our participation by on average 30 participants per meeting. So we almost doubled our numbers. However, the drawbacks of these virtual meetings is that the participants are not always able to devote 100% of their attention to the meeting as they would have to an in-person meeting. And also networking is more of a challenge. So this past year, although not ideal, we were able to figure out how to connect and share ideas virtually. And that's all I have. Thank you very much for joining.
Hello, I am Ryan Lee, NSRP's Workforce Development Panel Chair. It is my pleasure to provide you with the state of the Workforce Development Panel. Instead of a lengthy mission statement, I thought it best to get straight to the point. NSRP's mission is to reduce total ownership cost. The Workforce Development Panel's mission is to reduce total ownership costs through enhancing workforce capacity and capability and collaboration, leveraging best practices and investigating new technologies. Our purpose is to improve shipbuilding's workforce development ecosystem through projects that lead to implementations that attract new workers to our industry, develop or enhance pathways for skills development through standardizing curricula and developing nationally recognized portable credentials. We work to maximize training efficiency and effectiveness through projects that lead to implementations that reduce training time, increase training transfer, and mitigate remedial training. Also, we research and develop technologies and best practices to solve workforce challenges through projects that lead to implementations, to bridge internal skills gaps, and increase external workforce availability. Why is this important? Collectively, we are experiencing an aging workforce, lack of available technically skilled workers, lack of defined skill sets, increased costs in recruiting, hiring, testing, and training workers, increased competition among industry sectors, missed opportunities to leverage existing external educational infrastructure and resources, untapped federal, state, and regional funding streams, and underlined or siloed efforts, and a need to accomplish our mission more efficiently. Bottom line, as an industry, we have a lot of the same challenges in the same areas. While each company and region is unique, the fundamental problems are the same. There is work we can do together to make a huge impact. NSRP project implementations will add up to a universal solution to these larger fundamental challenges. The benefit to the U.S. Navy is our mission: reduce total ownership cost. NSRP's Workforce Development Panel provides a forum and a framework to collaborate and fund projects that prevent future costs, reduce schedule risk, reduce workmanship quality risk, and reduce reliability risk for U.S. Navy programs. At the end of the day, the workforce is the most critical resource, and labor is one of the most expensive cost items. The good news is, nearly every Workforce Development Panel project leads to at least one shipyard implementation. This can come in the form of training program implementation or pilot classes that act as an initial proof of concept but become permanent, resources to improve recruiting or training processes to help us compete with other industries, technology to make training and workforce development more efficient or effective. And we know future projects stand on the shoulders of past projects. NSRP's Workforce Development Panel is evolving shipbuilding's workforce development ecosystem one project at a time. While ROI for workforce development related initiatives at times can be difficult to quantify, there's no doubt the ROI potential is huge. If we have a project or a series of projects that lead to an implementation affecting 50,000 shipyard workers over, say, a 5-year period, by simply reducing training labor by 8 hours per worker, it would save roughly $20 million in overhead over the period. An implementation reducing training labor by 40 hours per worker would save roughly $100 million over the period. This is the goal of the Workforce Development Panel, to get good projects funded to reduce total ownership costs. So what is the state of the panel, and how are projects assisting shipbuilding and ship repair? Let's go back to our 3 focus areas: improving shipbuilding's workforce development ecosystem, maximizing training efficiency and effectiveness, research and developing technologies and best practices to solve workforce challenges. As stated, we are doing it through synergy and collaboration around a shared vision. This sounds fluffy, but it is really important. Workforce development issues are huge, complex, and diverse. It takes time collaborating to find overlapping solutions to these large fundamental challenges. We collaborate through panel meetings like this one, and other panel meetings or ad hoc initiatives. We collaborate through tech transfer and the larger NSRP framework. NSRP is unique in that it uses a competitive process to ensure the best ideas rise to the top and get funded. Ideas are resourced and turned into initiatives that are actioned. These actions of project teams deliver products and technical transfers for implementation. Right now, the Workforce Development Panel has 4 panel projects underway, plus a Manufacturing Engineering Education Program, MEEP, proposal that was not awarded, but is worthy of a mention due to the impact we believe it would have had. The important point is these 4 panel projects, which will be listed on the next slide, are doing a great work to improve shipbuilding's workforce development ecosystem. We have a high level of collaboration on these 4 projects with multiple shipyards participating. MEEP was an ONR solicitation for which ATI responded and submitted a full proposal on behalf of NSRP and the Workforce Development Panel. It is an opportunity to get $5 million in a 3-year project to advance a national workforce development system for shipbuilders, which includes portable credentialing. The title of the proposal is Next Generation Workforce Solutions for Shipbuilding and Repair. While we were not awarded the project, we see great potential for award in the future. This project has the potential to change our paradigm. In addition, we have 7 panel projects, including the previous 4, that will lead to implementations to maximize training efficiency and effectiveness. We have 2 panel projects developing technologies to solve workforce challenges. Let's take a moment to look at these projects and how they are providing a benefit to the U.S. Navy and the industry at large. Build Your Future and Women in Welding are establishing resources and a universal framework for shipyards to improve recruiting and training for entry-level talent, which is key for our industry right now. Miniature Torch is developing a technology that reduces the skill requirement for welding. Instead of accepting the costs associated with building better welders, we're developing technology to consistently improve weld quality to make welding easier, thus reducing the barriers of entry for new workers and costs. Virtual spray paint training researches the application of an existing technology to maximize training efficiency and effectiveness to reduce labor and overhead costs. The 3 certificate programs listed develop or enhance pathways for skills development. They are providing a framework for standardized curricula and nationally recognized portable credentials to improve shipbuilding's workforce development ecosystem. There is a lot of synergy here. We have good shipyard participation on these projects in alignment with the MEEP concept. This was just a preview. If you would like to learn more about these projects, I invite you to participate in the Workforce Development Breakout where you can learn more. In conclusion, panel membership and engagement remain strong and has increased through the pandemic. We are excited about the future and look forward to what comes next. This concludes my presentation, and I look forward to your questions. Thank you so much for your time.
Good morning, everyone. Welcome to the Planning, Production Processes, and Facilities Panel State of the Panel presentation. I know it's been a long year for everybody, and this is yet another online Zoom type meeting, and I assure you I'm taking it a lot more seriously than I have most other meetings. Before we begin, I'd like to start off with a quick message from our recently retired PPPF panel chair, Mr. Ken Fast.
Hi everybody, Ken Fast here. I want to thank Joshua for sneaking me into the program. I know some of you were expecting to see me in a Hawaiian shirt on a beach somewhere, but I thought what would be more lush and tropical than a New England backdrop in late winter, some snow on the ground behind me. I stepped down as panel chair in the fall, make way for some new leadership, and I think the panel's under good hands now with Joshua and Pat leading it. I retired at the beginning of March, so after 42 years of work and 32 years at Electric Boat and 22 years involved with the NSRP, I wanted to wish a belated happy birthday, 50th birthday to the NSRP, National Shipbuilding Research Program. I had done some research a while back on the origins and early workings of the program, and I was struck by 2 things. First, I was I was surprised that a government-initiated and government-funded program could be so useful and productive. And second, I was struck by how unchanged the workings of the program were over a 50-year span, that continues to do collaborative research and development, sharing of best practices, and does a great job of getting these shipyards who are arch rivals and fierce competitors to work together for the good of the government and the Navy and the ships that we build. So thanks for having me as part of the program. All the best to the National Shipbuilding Research Program, and hope to see you at a meeting sometime in the future. I'll be around for years to come. Thank you.
I'd like to personally thank Ken for his years of service and dedication to NSRP, his years of mentorship towards me through the PPPF panel, and I wish him all the best in his retirement, well earned and well deserved. As Ken alluded to, we've got some new leadership here in the PPPF panel. My name is Joshua Reese. I'm a 9-year Navy veteran, civil structural engineer. I spent the last 12 years with GD NASCO, and I've worked on a half dozen or so NSRP projects myself, most specifically within the PPPF panel. I'm an avid sailor. I do a lot of racing here in Southern California. The picture you see there is me delivering a boat back from Puerto Vallarta to San Diego last year, just before the pandemic hit. We also have a new panel vice chair, Mr. Pat Cahill, a U.S. Navy veteran, naval architect, marine engineer, and graduate of the U.S. Naval Academy with over 15 years of industry experience, most recently with his own company, Cahill Consulting. All right, with the changes in panel leadership discussed and now out of the way, I'd like to start talking about where the PPPF panel stands. Over the last 50 years, NSRP has been dedicated to reducing the total ownership costs and improving the capabilities of both U.S. government and U.S. flagged commercial ships. NSRP is broken down into 4 major initiatives: ship production technologies, business processes and information technologies, ship design and material technologies, and infrastructure support. The planning, production processes, and facilities panel sits just below the ship production technologies major initiative. The mission of the PPPF panel is to discover and disseminate the best practices related to the principal manufacturing efforts, most notably planning, production processes, facilities, and equipment. The PPPF panel seeks to improve the efficiency and quality of constructing a ship, including researching and evaluating advanced technologies, tools, and materials used during the ship production phase, examining methods to optimize build strategies and improvement to facilities, maximizing collaborative efforts with ship design and material panel to fully realize new technologies, tools, processes developed by both panels, and seeking collaborative opportunities in welding, coatings, and electrical technology. As the panel chair, I might have a little bit of bias in me, but I would consider the PPPF panel as the keystone to the bridge that helps industry cross the chasm and help achieve the overall goal of reducing total ownership costs. Now, I say this because if you look at every other panel, any project that they put forth, there is some aspect of planning, production process, or facilities that will need to be changed or challenged in order to implement that project. In a sense, you can say that the PPPF panel is where we begin the process of making everything more affordable. So a few data points to help support my keystone theory. Back in October of 2019, we had our last meeting, our last in-person meeting with the PPPF panel. I was in Bath, Maine, and I was attended by about 26 folks. It was a great meeting, a great tour of Bath Iron Works. And that said, BIW is not necessarily the easiest place to get to. So the fact that we had 26 folks able to make it says a lot. Since March of 2020, as you all know, we've had to go virtual. Our last virtual meeting was held in July of 2020, where we had 46 attendees. Now, the increase in attendees, given the less than desirable virtual format, really goes a long way to show just how important folks think the PPPF panel really is. And I'll go ahead and go on the record now and neither confirm nor deny that I wore shorts and sandals during that meeting. Given its large footprint across so many facets of shipbuilding, it's no wonder that the PPPF panel is also very flush with panel project proposals. Back in 2019, there were 3 PPPF panel projects selected for award. And that represented a very wide swath across member yards, including Austal, HII, and BIW. 2020 brought more panel projects to the PPPF panel. This time, the lead participant was GD NASCO. At present, all of the 2019 projects have been completed. The 2020 project, Additive Manufacturing Solutions in the Shipyard of Job Aid, Replacements, and Part Prototypes, is currently the only active PPPF panel project. An update on its progress will be provided at the panel breakout session. The trend of having a large number of projects proposed continued during the 2021 panel project solicitation cycle. The last panel project cycle had 11 projects submitted for the PPPF panel, of which 2 were selected for immediate funding, and a third was selected but waiting funding sources. I have no doubt that once the 2022 solicitations come out, we'll see this trend continue. Again, as Ken mentioned, NSRP is one of the few rare entities that is good at bringing academia, industry, government, and technology entities together in support of one common goal. Through this medium, and the PPPF panel specifically, we've been able to come up with numerous creative, innovative, and cost-saving manufacturing methods to help NSRP reach its goal of reducing the total ownership costs and improving the capabilities of both U.S. government and U.S. flag commercial ships. NSRP provides the collaborative framework necessary to help us all learn from our mistakes or our successes. And again, with all the areas that the PPPF panel touches, there's no doubt that it will continue to be a major contributor to the benefit for the U.S. Navy. And with that, I can tell you I've gained a newfound respect for YouTube superstars. This has been a presentation I've had to give unlike any other. Well, thank you all for your time today. Hope you enjoyed the presentation, and I hope to see you all later this week at the PPPF panel meeting. Have a great day.
Good afternoon, everyone. I am Jamie Brakefield from Ingalls Shipbuilding, and I am going to be presenting the state of the panel for the Business Technologies panel that includes the Digital Shipbuilding Committee. The Business Technologies panel falls under the major initiative of Business Processes and Information Technologies. Our major initiative team leads are Michael Girardi from General Dynamics Bath Iron Works and Patrick Hilgendorf from Austell, USA. And this is our target area for the Business Technologies panel. Next, we'll talk about the structure of the Business Technologies panel. As mentioned earlier, that it does include the Digital Shipbuilding Committee inside the panel. I'm the panel chair. We have our vice chair, Patrick Roberts from SSI USA, and then we also have the Digital Shipbuilding Committee chair, Patrick David from SSI USA. Our Business Technologies panel mission. We want to focus on emerging technologies, research, and education, but really our main focus is using technology to improve processes, but only where it's appropriate. We want to take a look at managing information and developing advanced solutions that support product lifecycle from concept to disposal. The panel's purpose. What do we actually do? One of our big purposes is to provide collaboration for the marketplace, the industry, and to Navy to look at innovative technologies. And why do we do those things? We want to strategically align ourselves with the Navy initiatives. Our big targeted initiatives are digital shipbuilding, which would include the integration of enterprise processes and tools to support digital shipbuilding, including things like internal and external PLM, manufacturing execution systems, data exchange, modeling, and simulation. Our second targeted initiative is cybersecurity compliance solutions, education, and awareness. So what we really want to do with the panel is increase the awareness of cybersecurity best practices for enterprise processes and tools, model-based enterprise. We want to introduce the compliance solutions for enterprise processes, as well as investigate solutions for protecting data systems. And specifically, we want to focus on getting the education and awareness out to the industry. Our third targeted initiative, information management, is where we want to identify solutions and best practices for data configuration management and governance, identify and propose standards for data exchange, data delivery, interoperability between internal and external systems like CAD, PLM, MES, scanning, and cloud technologies. And we want to implement innovative solutions for shipbuilding informatics like data analytics and business intelligence and reporting. Our fourth targeted initiative is emerging technologies and business processes. And this is really for us sort of a catch-all for all the other things that we want to target with the panel. Exploring the evolution and feasibility of emerging technologies to improve shipyard efficiencies, things like additive manufacturing, autonomous systems, industrial Internet of Things, mobile technologies, knowledgeware, AR, VR, scanning, robotics, anything that falls under the emerging technologies. So back when the Business Technologies Panel was first formed, we put together a Business Technologies Panel roadmap. And that's really for us just to lay out what the panel wants to focus on throughout any given year and then the next couple of years. This is an excerpt from our 2021 roadmap, and we consider this a living document, so it could change throughout the year or between one year to the next year, but it's really just a tool for the panel to use to keep our focus on individual items. A little bit about the Business Technologies Panel meeting attendance. Prior to last year, our average for in-person attendance was around 32. We actually had quite a significant increase since we've been doing virtual meetings during the pandemic. As you can see, it almost doubled. So even before and during the pandemic, we've had great attendance to our panels. The next thing I want to talk about is the benefit and assistance to the Navy and shipbuilding and ship repair industries from the panel. So if we take a look at the NAVSEA Warfare Center strategic plans, their goals are things like empowered workforce, technical and business excellence, enhanced partnerships. And their objectives are things like develop and sustain required capabilities, modernized physical and virtual infrastructure, transform and improve technical and business processes. You can see from taking a look at these goals and objectives, if you were to compare the same goals and objectives for the shipbuilding industry or an individual shipyard, there would be a lot of crossover and a lot of the same goals and objectives. Now let's take a look at the Navy and Marine Corps Digital Systems Engineering and Transformation Strategy. Their objectives are things like formalize the development of integration and use of models, enduring and authoritative knowledge source, technological innovation to improve engineering practice, infrastructure for supporting digital engineering practice. And again, if you take a look at these objectives, you're going to have a lot of crossover between what the objectives of the shipbuilding industry is and what the Navy's objectives are. So what does the Business Technologies panel bring to the table to benefit the Navy and industry? So what we feel is we provide a forum for the collaboration between industry, Navy, and the vendors. The Navy and the industry are both in the midst of digital transformation, and the Business Technology panel focuses on initiatives that benefit both the Navy and the shipbuilding and repair industries. And what we like to do is take a look at where is the crossover between the Navy, the shipbuilding industry, and the ship repair industry. What are the things that we can attack that will benefit all of those entities? We want to take a look and understand common problems and have a vision towards providing solutions to those common problems. Just to take a look at some past and current projects from 2019 and 2020, a really good example of this is support delivery of shipbuilder product and technical data to an in-service Navy PLM for all classes of ships. We had a lot of participation from NAVSEA and a lot of participation across the shipbuilding industry on that project. That's a really good example of where we want to support both the Navy and the shipbuilding industry. And then we have more specific projects like our Express Marine integration, the knowledge provisioning to improve and simplify the ABS digital compliance, the structural interface for automated compliance checking, the simulation workflow development for additive manufacturing. These are also projects that we feel like benefit both the Navy and the industry at large. Just to take a look at what the future panel activities are, we would invite you to join us on March 24th for our virtual meeting that's associated with this all-panel meeting at 1 Eastern Daylight Time. And then we're looking to have further virtual panel meetings in June, August, and October of this year. Those are not firm dates, but that's sort of a tentative list of where we want to be. We also always look to collaborate with other panels, and then we're looking to plan for those future in-person meetings as soon as those are viable. With that, that's everything that I had for today. I want to thank you for your time and attendance, and look forward to seeing you at our meeting on the 24th.
Good morning. My name is Yaniv Zagagi. I'm from Golder Associates, Inc., and I am the Environmental Health and Safety Panel Vice Chair. In this session, I'd like to introduce the EHS panel and discuss past, current, and future activities of the panel. The panel's mission statement is to research, develop, and sustain current and emerging environmental health and safety, to promote and improve health and safety, wellness, and environmental stewardship of shipyards. The panel provides an open and interactive forum to promote technology transfer and broad industry interaction in support of the NSRP mission to reduce the total cost of ship construction and repair, and in our case, which is very important as well, is reduce injuries and reduce environmental impacts. The panel's main focus areas is to promote research to develop or refine processes, tools, and programs that reduce safety, health, and environmental risk, monitor and evaluate the impact of new regulations on the shipbuilding industry, strive to reduce work-related injuries and illnesses, impact the development and retention of skilled workers in shipbuilding and repair, strive to reduce the impact of shipbuilding and repair on the environment. The current panel activities are divided into two parts, the panel projects and panel meetings. The three notable projects were completed recently in our panel. The first one is a wearable ergonomic sensor technology. That project dealt with relatively new technology that is wearable, and it captures physiological aspects of the job, including body position, body movement, biometric, and other data, in order to evaluate each job with regard to the scale of difficulty and the potential for body motion injury. A lot of these technology is not designed, it's not robust enough for ship repair activities. And part of this program was research project was to identify whether we can use this or how we need to improve this technology in order to be able to capture data in the shipyard industry. The second panel project is Navy tank study for robotic application. What they did, they evaluated different tanks across multiple ship platforms and categorized them based on similarities and differences. So these tanks that they share the most common, can be identified and evaluated for common robotic solution in the future. That way you can move a robot from one platform to the other. As long as the tanks are similar, the robots will be able to do the work that they need to do without learning on every tank by itself. The third research panel project was a short course on dredging fundamentals for shipyard operation and environmental sustainability. That project involved the development of and presentation of a one-day short course devoted to various aspects of successfully planning and implementing maintenance and cleanup dredging project at shipyards. The second part are the panel meetings, which are very critical. We meet at least twice a year. Recently web meeting, but we do the best we can. Big part of the meeting has to do with transfer of knowledge on information between the different shipyards, and as you know, shipyards here are covering the entire country from east to west, from north to south, so they don't get to meet too often. And during these meetings, we talk about different aspects of health and safety and environmental. For example, worker compensation, different lawsuits, different compensation that companies had to pay, different programs that they have to reduce worker compensation exposure, environmental discussions as far as new rules, how different companies comply with different rules, updates in the programs, what works, what doesn't work, and the same for health and safety. We discuss injuries, rates, even sometimes lessons learned of severe injuries, and God forbid, sometimes fatalities. What happened and what we can learn from other people's experience that will hopefully not happen in our shipyard. We also discuss panel projects and other topics such as regulatory topics that come up and worth discussing. For instance, the PFAS risk for shipbuilding industry, that I'll get to that in more details in the next slide. My last slide discusses future panel activities, and again, they're divided into panel projects and panel meetings. The first panel project that I'll introduce is identifying, evaluating, and mitigating ocular hazards. This panel project was approved for the 2020, but was delayed due to COVID issues. Hopefully it will start very soon. The goal of this project is to measure and determine means to mitigate ocular hazards that are associated with laser surface preparation, the process that we'll use in an area where controlled environment is not possible. As you know, laser is used more and more in the industry. In this case, laser was sought to enable faster, cleaner, less laborious, and more cost-effective method of surface preparation or coating removal. The issue with laser, it's got ocular hazards, and the purpose of this project is to identify, learn, and how to control and be able to properly control ocular hazard while using laser inside a contained area or confined area such as tanks. The second project deals with industry-wide collaboration to address the Navy's shipboard industrial fire safety program. As you all know, recently there were several fire incidents, severe on ships, and the idea is to undertake a pilot initiative in industry-wide communication and collaboration on standard and best practices associated with the control of combustible materials and other flammable materials. This offer tackles a single problem and establishes the foundation for future work needed to reduce the number and severity of shipboard fires, which in turn reduces the number of lost operational days that occur during ship construction and or ship maintenance availabilities. The third panel project that was approved for 2021, the second that was approved for 2021, and hopefully will kick off soon, is high productivity, reduced emissions, and arc gouging processes. The goal of the project is to reduce the cost and increase the safety, productivity, and environmental quality of metal removal using an arc gouging process. Again, just like the laser, these are processes that are relatively new and not well understood in the shipbuilding industry. The system that we're going to evaluate, it's called WELDVAC, can have an enormous impact on ambient environmental quality by virtually eliminating the spatter, slag, fume opacity, carbon dust, and noise while conducting carbon outgouging, which is very, very loud and usually causes a lot of environmental and health impacts, or may cause environmental impacts. The fourth panel project is on standby. Hopefully it will get approved. And that's an environmental research that deals with per-polyfluoroalkyl substances, commonly referred to as PFAS. Recently, the EPA, under the Resource Conservation and Recovery Act, added the PFAS into the annual toxic release inventory reporting requirement. This is a brand new requirement, and the purpose here is to attack the significant regulatory attention that is given to PFAS now, because PFAS in the environment, they don't go anywhere, they stay forever. So the idea is to learn how if these PFAS are an issue in the ship repair activity, and if so, how they can be controlled and help the shipyards develop proper control of these hazards, environmental hazards, and also properly report them in the annual TRI reporting. The second part is the panel meeting. So we're going to meet part of the all panel meeting, but also we're going to have a fall meeting, and hopefully maybe by then we'll be able to meet face to face. But in any case, like any other meeting, we always, again, discuss lessons learned in roundtable. It always starts with a roundtable, work on compensation, environmental health and safety. We try to visit different shipyards and different manufacturing activities related to shipyards as part of the panel meetings. And again, go over regulatory updates and updates for panel projects that are going on during that time. And that's it. And that's it for my slides, and thank you very much.